All right, welcome back for Chapter 3, Exponents and Roots. Today we're discussing Lesson 8, the Pythagorean Theorem. So, the Pythagorean Theorem relates the side lengths of a right triangle. So it's really, really important that we know that this Pythagorean Theorem only applies to right triangles. And right triangles are triangles, remember, that have one angle which is 90 degrees, and that little mark right there signifies that it's 90 degrees. Okay, so what is the relationship of this Pythagorean theorem with a right triangle? And it's actually kind of cool. It's like, how does that work? Let's go ahead and look at it. So what the Pythagorean theorem says is if you take the length of this side and square it, and you take the length of this side and square it, that E is the same as the length of this side, this way. So whenever you have a triangle and a right triangle, each side has a particular name, okay? So they call this one, okay, right triangle, the side that's directly across from this 90-degree angle, that's called the hypotenuse, okay? And with the Pythagorean theorem, they call this letter C. And then these are the sides. And this is just a side, and this is another side. And a lot of times they call this A and this one B, or this one could be A and this one could be. It really doesn't matter if this is A or that's B. The thing that matters is this C, this hypotenuse. This is always the hypotenuse. Now, what it says is in a right triangle, the sum of the areas of the squares on the legs, oh, they call these legs, my bad, sides, legs, they're called legs, is equal to the area of the square on the hypotenuse, right? So let's count this up. So let's see if that's true. So this side length is 1, 2, 3, okay? So this is a square, so a 3 by 3 means there's an area of 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's saying if we take that 3 squared, that would be right here. So this square, and we add it to this square right here, which is a 4, 1, 2, 3, 4, and we're talking about the area, so it's going to be a 4 by 4, and 4 times 4 is 16. Okay, so if we take this square, which would be 4 squared, right, which is 16, and 3 squared is 9, what it's saying that if you add these up, that is the same thing as this. So let's add them. Okay, so what do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So if you add these two squares together, this one and this one, they equal 25. Now we just have to see, well, what is the area of this one? Okay. Because it says, the Pythagorean theorem says that this square plus this square adds up to this one. And let's see. Let's count it out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. It's the same. Isn't that crazy? So this was a length of 3, this was a length of 4, and this is a length of 5. So the Pythagorean theorem states that if you take this side and you square it, and you add it to this leg and square it, that is the same thing as the hypotenuse squared. 3 squared is 9, 4 squared is 16, 5 squared is 25, and if you add these two together, 9 plus 16 is 25. And so it equals, isn't that crazy? I just think that's the coolest thing. So let's talk about the Pythagorean theorem. I kind of already talked about this, but let's just go ahead and review it. So you know where it derives from. It derives from the area of squares, but only with a right triangle. This right triangle piece is super important. It has to be a right triangle. If it's not a right triangle, then it doesn't work, okay? So the Pythagorean theorem, in any right triangle, there it is, the sum of the squares, okay, there's a square, the sum means we're adding them together, of the lengths of the two legs is equal to the square of the length of the hypotenuse. So, and here you go. There's our right triangle. Here's our two legs, A and B, and there's our hypotenuse, C. Okay, and then that's the example that we just looked over. So this is the Pythagorean theorem. A squared plus B squared equals C squared. So you take this leg and you square it. You take this leg and you square it, and that equals the square of the hypotenuse. Okay, so let's go ahead and look down here. It says, without drawing the squares, can you find the length of each side? Okay, so let's look at this. Here's our little problem right here. It's a right triangle, so I know that the Pythagorean theorem works, so I'm going to write a squared plus b squared equals c squared. And then I'm going to define my variables. Okay, so this is a side. I'm going to say a is equal to 3 and b is equal to 4. Okay, now I'm going to substitute these values in for the variables. And so a is 3, so that's 3 squared. Plus b is 4 squared equals c squared. 3 squared is the same thing as 3 times 3, which is 9. 4 squared is the same thing as 4 times 4, which is 16. C squared, right? So 9 plus 16, that's 25. Now we got to find out what c is, and c is squared, so we have to do that inverse operation. What's the inverse operation of a squared number? Well, it's a square root, right? So I got to take the square root of both sides. This square and that square root. Well, this square and that square root cancel each other out. So now I'm left with c. And the square root of 25, 25 is a perfect squared, right? Which means it's the same thing as 5 squared. Square root and squared cancel each other out, and we're left with c equals 5. You know, there's a positive and a negative, but since we're talking about distance here, we know that our answer has to be positive because we can't have negative distance. So there, that's how we do it algebraically, and that's the way that we're going to be using it to solve these problems. However, I wanted you to understand that this is derived from this, for a right triangle, from the sum of the squares, and these two squares added together equal the area of the square for the hypotenuse. Okay, perfect. Now let's look at some other examples here. Okay, so finding the length of a hypotenuse, find the length of each hypotenuse to the nearest hundredth. And remember that hypotenuse, that is the side across from the 90-degree angle, which would be this one right here, okay? So let's go ahead and figure this out. So we know that we're going to be using the Pythagorean theorem. We have a right triangle, right? So I'm going to write that. Okay, this is how I want you to show your work on your homework and quizzes and tests and all that. A squared plus b squared equals c squared. We're going to define our terms. It doesn't matter which one we call a and b. I'm just going to pick one. So I'm going to call this one a. A is equal to 4 and b is equal to 5. Then I'm going to substitute those values in. So I get 4 squared plus 5 squared equals c squared. Okay? Now I'm solving for c, which is the hypotenuse, so I'm trying to figure that out. 4 squared is the same thing as 4 times 4, which is 16, plus 5 squared is the same thing as 5 times 5, which is 25. And 16 plus 25, what is that? Take it over here to the side. That would be 11. 41. 41 equals c squared. Then I need to get c by itself. So I'm going to square root both sides. This square root and that square cancel each other out. So I am left with c equals the square root of 41. Now the square root of 41, this is not a, it's not a perfect square, right? So really, I'm just going to use my calculator here to figure out what that is, because in the instruction is it says round to the nearest hundredth. So I'm going to go here, clear that out. We're going to go second square root of 41. And what do we get? Okay, hundredth would be 10th hundredth, so that is not bigger than 5. So it just stays 6.40 or just 6.4. And so we're going to say C is approximately 6.4, but it is equal to the square root of 41. And that is our final answer. All right, perfect. Let's go on to the next one. Okay, B. All right, so we have a right triangle again, okay? So we know that we can use that Pythagorean theorem to figure out what this side is, the hypotenuse, which is directly across from that 90 degree. So I'm going to go ahead and write the Pythagorean theorem down. A squared plus B squared equals C squared. And yes, I want you to write this every single time and also define your terms. So let's say that A is equal to 5 and B is equal to 6. Okay, we substitute these values in. So we get 5 squared plus 6 squared equals C squared. 5 squared is the same thing as 5 times 5, which is 25. Is this the same problem? No, it's not. Okay. And 6 squared is the same thing as 6 times 6, which is 36. Okay, I don't know. All right, then we add these. So I'm going to take this over to the side and add it up really quickly. 5 plus 6 is 11. 3 plus 2 is 5 plus 6 is 61. So we have 61 square root. Okay, we want to get C by itself, so we're going to have to use that inverse operation of a squared number, which would be a square root to both sides. Okay, so we end up with the square root of 61. We know it's a positive and minus negative, but since we're referring to distance, we're going to use the positive one. So we know C is the square root of 61. That's exactly, right? This is an irrational number, so the decimal's going to keep going on forever. What do we know? What is an estimate of this number? Well, we know it's between, what, 64 and 49? Yeah, so it would be 7 point something, probably 7.8, because it's really close to 64. Or 7, yeah, I guess 7.8. But it says to round to the nearest hundredth, so I'm going to go ahead and use the calculator to figure that out. My guess would be like 7.8. Let's see. Ooh, 7.81, and that's a 0, so that means that one stays, right? So approximately, and see how the number goes on and on forever, and see this one actually rounds it as well. The number would keep going, but because of this computer screen, it can only, fit so many digits. It can't fit in a limited amount of numbers, so they have to round as well. So C is approximately 7.81. And that's how you do it. So we have the exact number and the approximate number to the nearest, rounded to the nearest hundredth. All right, let's go ahead and look at C and D. And this time I want you to try them on your own. So here's my friend the pause dragon. Remind you to pause your device. Go ahead and work out C and D. When you get done, press play and we'll talk about it together. All right, see you in a bit. You can do it. All right, let's see how you did. So the first thing I'm going to do, right, it's a right triangle, so I'm going to write down that Pythagorean theorem and then define my terms. A squared equals B squared equals C. A squared plus B squared equals C squared. And then here, A is equal to 8, B is equal to 8. We substitute those values in. Okay, we know that 8 times 8 is 64 plus 64. All right, then we add these two numbers. 60 plus 60 is 120, then 4 plus 4 is 8, so 128 equals C squared. Okay, I'm trying to get C by itself, so I have to do the inverse operation, which would be a square root to both sides. Square root cancels out a square, so we're left with C, right? And what I want to do here, the square root of 128, I want to get this into exact form. So square roots cancel out squares. So my question is there a squared number within 128? And I think there is. I think 4 is a square, it's a perfect square number, right? And it goes into 128. I'm not exactly sure how many times 4 goes in, but I can figure it out. So 4 goes in 3 and 2, so 32 times, okay? So I can rewrite 128 as the square root of 4 times the square root of 32. Because 4 times 32 is the same thing as 128, right? So what do I know? I know that the square root of 4 is the same thing as 2 squared. And that square root and that squared are going to cancel each other out, and I'm just going to be left with 2, right? So I'm going to be left with 2. Now, the square root of 32 also has a squared number, a perfect square number in it as well. I want to say 16. 16 times 2. So I can go the square root of 16 times the square root of 2, because 16 times 2 is 32. Now, the square root of 16, that is the same thing as 4 squared, right? And then this square root and that square cancel each other out. And so basically I'm left with 2 times 4. This 2 and that 4 are square roots of 2. And 2 times 4 is 8. So this is the exact simplified form. 8 square roots of 2. Okay? But we also have to give the approximate value. So let's go ahead. What do we have up here? Square root of 128. So I want to go ahead and do that one first. So square root of 128 is equal to 11.31, and we don't round it, so it's just as C is approximately 11.31 rounded to the nearest hundredth. But I also want to put this one in so you see that this is exactly the same. This is the exact form simplified down. So if we go 8 times the square root of 2, see, we get the same thing. All right, so yeah. So if you have this answer and this one, great job. If you only got to square root 128, I want you to go ahead and write down these notes in your notes so you have exactly what I have written here. Okay, let's go ahead and see how you did on D. So again, we have a right triangle, so we know that we're doing that Pythagorean theorem, okay? So I'm going to go here. Oh, sorry about that. A squared plus B squared equals C squared. Let's say A is equal to 12 and B is equal to 5. Then we just substitute those values in. Right, 12 squared is the same thing as 12 times 12, which is 144, plus 5 times 5, which is 25. And this ends up being 169. Ooh, I think I know what that number is. Okay, so then we have to get C by itself, so we have to do the inverse operation of a square, which is a square root. We square root both sides. The squared cancels out, square root cancels out with that square. We're left with C. And then 169 is a very special number because it's a perfect square. This is the same thing as, 13 squared. So this square root and that square cancel each other out. And we're left with C equals 13. Sorry, my pen keeps hitting it and making it bobble. And that's it. That's our final answer. So if you got that one right, great job. Okay, now we're going to do the same thing, but it's going to look a little different because we're going to move on to coordinate planes. So it says find the length of each hypotenuse to the nearest hundredth. We have a triangle with these coordinates, so I have to plot those coordinates first. So let's go -7, 0. So this would be -1, 2, 3, 4, 5, 6, 7. Okay, so right here, that's 1 point. -7, -6. So we know this is -7. -6 would be down here. 1, 2, 3, 4, 5, 6. Okay, and then 1, 0 would be right here. Okay, so I'm going to make this triangle here and connect these dots. I'm going to use my little highlighter to make it just a little bit more pronounced. Just looks so pretty with the highlighter. Okay, so this is our right triangle, and we know that since we're going from a horizontal to a vertical right here, this is our 90-degree angle, okay? Now, since this is a right triangle, we can use a Pythagorean theorem, so I'm going to write that down. a squared plus b squared equals c squared. Now, it's asking us to find that hypotenuse, and remember that hypotenuse is directly across from the 90-degree angle, which would be this one right here. This is the hypotenuse. So this is what they're trying to have us, hypotenuse, figure out, and that's our C, okay? So let's go ahead and label our sides. So A is equal to, I'm just going to call this side A. So this is 1, 2, 3, 4, 5, 6, 7, 8. So is A is equal to 8. And B would be right here. So the side length of this is 1, 2, 3, 4, 5, 6. And it's nice just because you can count. B is equal to 6. All right, we just substitute those values in. So 8 goes in for A. And 6 goes in for B. 8 times 8 is 64. 6 times 6 is 36. Ooh, this is going to be a fun one. 64 plus 36 is 100. Oh, it makes me so happy when there's perfect square numbers right here. Okay, so then we have to get C by itself, right? So we're going to do the inverse operation of a square, which would be a square root. Square root and the square cancel each other out. We're left with C, and 100 is the same thing as 10 squared, right? So that square root and that square cancel each other out, and we're left with positive and negative 10. However, we're talking about distance, and distance is always positive, so that means it's 10. And I'm just going to go ahead and write it like that. So C is equal to 10. That is the length of our hypotenuse. Woohoo! Okay. Now we're going to move on to F. And this one, I want you to try to do on your own, okay? So here's my friend. We're supposed to find the hypotenuse, right? Here's my friend, the pause dragon. I need you to pause your device. Go ahead and work out F. When you get done, press play and we'll talk about it. All right, see you in a bit. Okay, let's see how you did. The first thing we have to do is plot these points. So negative 4, 2, 1, 2, 3, 4, up 2. 4, negative 2, so positive 4, 1, 2, 3, 4, 1, 2 down here. And then negative 4, negative 2, so 1, 2, 3, 4, down to 1, 2. So that would be right here. Okay, so this is our triangle here and to right there. Okay, so this is where the vertical and the horizontal meet. So this is our 90-degree angle. We know it's a right triangle, so we can use that Pythagorean theorem. A squared plus b squared equals c squared. And we are trying to determine what that hypotenuse is. That is our C right here, directly across from that 90-degree angle. So let's figure out what our A is. Our A is 1, 2, 3, 4, 5, 6, 7, 8. So we got A is equal to 8. And B is equal to 1, 2, 3, 4. B is equal to 4. So A is equal to 8, and B is equal to 4. If you had B equaling it and A equaling 4, no problem. Those types of things will happen. Okay, so we substitute in. We get 8 squared plus 4 squared equals C squared. 8 times 8 is 64, plus 4 times 4 is 16. Equals C squared. Okay, so those two added together, what is that? 64 plus 16. That's 10, and 6, that's 8. So we have 80, all right, is C squared. And we want to get C by itself, right? We're trying to figure out the distance of the hypotenuse. So we have to use that square root. Square roots cancel out squared numbers. To both sides, square root and squared cancel each other out. All right, so we're left with the square root of 80. Now we want to ask ourselves, is there a squared number, a perfect squared number that is a factor of 80? And I think there is, right? I think 4 goes into 80. So I know that 4 times 20 is 80. So I'm going to go here and go square root of 4 times the square root of 20. But I also think there's a squared number in 20. So we want to put this in exact form, right? So we want to get all the perfect squared numbers out of, simplify all the perfect squared numbers out of this number 80. So I also think that 4 times 5 is 20. So we're going to have the square root of 4, and then the square root of 4 times the square root of 5. So 4 times 4 times 5 is equal to 80. So 4 times 5 is 20, times 4 is 80. So all of this is the same thing as 80, it's just written differently. And you can do that. So the square root of 4, right? 4 is the same thing as 2 squared. This 4 is the same thing as 2 squared. And then we have 5, right? So square root and squared cancel each other out. Square root and squared cancel each other out. We are left with 2 times 2, which is 2 times 2 is 4 square roots of 5. So this would be the exact form. C equals 4 square roots of 5. Okay, so that's going to be one of our answers, and then we want to have that approximate answer, right? So I'm going to use my calculator, and first one I'm going to do is just the square root of 80, okay? I'll put it right here. So clear this out. The square root of 80 ends up being, because that's the n simplified version, 8.94. So we don't round that up, it just stays. So C is approximately 8.94. But I want to show you that for the exact form is the same thing as this. So I'm going to clear this out. I'm going to write 4 times the square root of 5. And see, it's the same thing, 8.94. Perfect. So if you got all that right, awesome job. If not, go ahead and change your work so your work looks exactly like mine. All right, that is it for this example. I'll see you in a little bit for example 2.